We're back to learning JavaScript on Exercism. This time I'm going to talk about Pascal's triangle. You should find it right here. So we are given a number of rows and this should create this number triangle. You've certainly seen this in your math classes at some time. So every row starts with 1. Let me just define number of rows. You can see that right here with the tests. When we have 5, we will get 5 rows. When we have 0, we would get an empty array. So let me take care of that first. So I define a new array. We're going to return it in the end. And if number of rows exists, so it's bigger than 0, we will return an array with a 1. And if not, we will return an empty array. You can see that in test 1. Let me scroll up. So when it's 0 for number of rows, we will get this empty array right here. Therefore, we've got test 1 covered. And now we want to create a nested loop for the rows and you could say the columns of the triangle. So create 2 for loops. One is nested inside of the other. The outer one will go through the rows and the inner one will go through these arrays. So these nested arrays one by one. If you're unfamiliar with the triangle, it's simply explained like so. Let me start here. For example, 3 plus 3 is 6, 3 plus 1 is 4. And this is how this triangle works. Maybe if I go to a bigger example, it becomes more obvious. Here, for example, 6 plus 4 is 10, 4 plus 1 it would be 5, and so forth. So we need to find a way to add up these neighboring values. Let's first take care of the rows with the outer loop. So for let row, which is the individual row, equals to 1 row smaller than num rows, row plus plus. This is, you could simply say, a row counter. And every time we have a current row, we will simply set this to 1. So every row starts with a 1, therefore we can add that here. Now we'll take care of the inner row, so the inner dimension. For example, right here, 1, 3, 3, 1. And I simply call this x. This is the counter for it. We'll set it to 1. As long as it's smaller than our row, we'll set it to x plus plus. And we want to push to our current row, which in the first iteration has only a 1. We want to push our array right here. And the index positions for it are our row counter, but -1. So don't forget that index numbers always start with a 0. So we want to have row -1, which would be 0 in the first iteration. And for the second dimension, we'll use our x counter. We'll also use -1 because we've set it to 1 and we want to start at the first index, which would be 0. And then we want to add the neighboring cell, so row -1 once again for the same row, but then x without -1. So in the case of 1, 3, 3, 1, we would add 3 to 1 in the first iteration, or at least the first iteration for this row, and that would give us 4. So this code line finds the neighboring cells in every of these second dimension arrays And when we're done with this, we want to add to our current row A1, so we'll use push for that. And we'll push it to our array. And this is what gives us the correct results. Don't forget to return it in the end. And if I haven't made any typos, we should be good here. And for example, show you test 4, so we will get 1 in the first iteration, then we get 1, 1, then 1 to 1, and so forth. And this is how I solved this Pascal's triangle exercise on Exercism. I hope this video was helpful, thank you for watching, and I'll see you next time.